All right, today we are going to start a process called linear programming. And everything that we're going to do today, almost everything we're going to do today, is stuff that you've already done. We're going to kind of tie together everything that we've talked about over the last couple of weeks. So you need to have this in front of you, but I want you guys to flip to the back of the second page, problem number 2.
You mean the back of the first page?
The back, yes, the back of the first page, yes. All right, it says that suppose you are a farmer. Suppose that you have 240 acres of land available to grow corn and oats. And you have 320 hours available to you to harvest the corn and the oats. It takes 2 hours of labor to harvest the corn. It takes 1 hour of labor to harvest the oats. How many acres of each should be planted to maximize your profit? I read this problem and I think words. There's lots and lots and lots of words, and I know that that's going to cause some of you some grief. So I am going to do my best to help you guys take those words and transfer them into math. And I don't think it's going to be horrible. You'll try it a few times and hopefully you'll get the hang of it. But it asks you this. What we're going to do is come up with some inequalities here. We're going to graph the inequalities. We're going to shade. And then you're going to take that shaded region and you're going to take it one step further. So what you need to do, first of all, is that one of the first questions is, what does an x represent? So in this problem, what do the x's represent? Well, most of these problems, I'm going to give you a graph. And on the graph, the x-axis is going to be labeled. So look at your x-axis, you guys. Look at what does it say on the x-axis?
Acres of oats.
Acres of oats.
Oh, you said the x-axis, right?
Oh.
On the x-axis, yes?
That says corn.
Acres. Oh yeah, I'm sorry, you're right, it does say that. I was listening to Kevin trying to be funny.
What?
So an x represents acres of
Wow.
corn, right? What does a y represent?
Acres of oats.
Acres of oats. I'm going to go to the y-axis, it says acres of oats, so that's what the x and the y represent, and we are going to try to figure out how many acres of corn should I harvest and how many acres of oats should I harvest, and you'll see the process as we work through this. But it says objective function. Objective function. That means your goal. Your goal. What is the goal of this problem? Well, if you read right above, it says an acre of corn will make a profit of $40, while an acre of oats will make a profit of $30. You guys, farmers harvest food to make money, right? So the goal of them putting all of that work into their crops is so that they can make money. So they are going to make $40 off of an acre of oats. They will make $30 off of an acre of, did I say that backwards?
Yeah.
Corn is
You should
40
label
acres.
some stuff.
Corn, $40, sorry. Corn is $40, oats is $30. So when you are writing your objective function is to make money, to make a profit. You will make $40 off of corn. So I'm going to write 40 times x. Why am I writing 40 times x? I make $40 for every acre of corn, and corn is my x. Would you agree?
Yeah.
How much money do you make off of a y? $30. So my profit is going to come from multiplying 40 times the number of acres of corn that I sell, plus I'm going to make $30 times every acre of oats that I sell. Okay. That is my profit function. This is going to become very, very important, but we're going to set it aside for right now. You don't need this until you get to the very end of this problem. What we need to do right now is worry about land. Because there's some issues here. We can't plant an endless number of acres of corn and oats. I have some constraints. I have some problems or some situations that I need to follow. How much land do I have available to me? 240. Okay. So what I would like you guys to do right now is take your pencil and I want you to underline everywhere that you see something about acres of land. Everywhere that you see something about acres of land, I want you to underline it. Would you guys agree that that's the only time that you see something in here about acres of land?
Yeah.
What are we harvesting? What are we going to put on that acres of land?
Corn and oats.
Corn and oats. X's and Y's. Would you agree? X's and Y's. So together, the number of X's that I plant plus the number of Y's that I plant, they have to give me
240.
less than or equal to 240 acres. Are you guys okay with the less than or equal to?
Yes.
I can make 240 or I can make less than. Okay, so that means X plus Y is less than or equal to 240. Now we need, there's a time constraint here too. We only have a certain amount of time to work with. So what I would like you to do is everywhere you see something about time, in this case the time is all in hours, would you agree? We're talking hours here. Everywhere you see an hour, I want you to circle it. Not circle, yeah, circle it. We have 320 hours available to us. We see 2 hours right here, and we see an hour right here. All of that hour stuff has to go together. I have to make one inequality out of all the time stuff. How much time does it take to harvest corn? It says 2 hours, doesn't it? Look what it says. It takes 2 hours of labor to harvest the corn. So when I write this constraint, I'm going to do 2x plus y. How much time does it take to harvest oats? 1 hour. So we have 2x plus, I'm just going to write y. No need to put the 1, y, all right? How much time do we have available to us? 320. All right. Can I use all 320 hours?
Yes.
Can I use 321 hours?
No.
Can I use 319 hours?
Yeah.
Yeah. So my point is that we can use all 320 or we can use less than it. So we're going to do less than or equal to 320. The hard work is done. Now it's just a matter of solving for y, plugging it into our calculator, making tables, finding points, and so on. So I have to scroll up a little bit here so I can get to my graph. So I'm going to be asking you guys to read these things to me in just a second. All right, we have to solve for y. So why don't you guys go ahead and start doing that right now. Solve for y. In the first problem, it was x plus y was less than or equal to 240? Okay. What do you do to solve for y? Minus the x. So y is less than or equal to 240 minus x. Type it into your calculator. 240 minus x. Now, to come up with some points for you to plot, you guys remember your points have to fit on this grid. So if I could have eyes and ears up here just for a second. Go to second window. We got to set up our table. Where should our table start? At 0. What are we counting by on the x-axis? 30s. Make your table count by 30s. Okay? Start it at 0, count by 30s. Make a table. And I need a couple points that are going to work. We're going to fit on this grid. 0 to 40. When you can, use your x and your y intercepts. They will be helpful later. 0 and 240. I need another point, and I think there's maybe only one other point that will fit. 120 and 120. Actually, I think maybe there's more than one in this case. 120, 120. That one will work. I'm going to go over to 120. I'm going to go up to 120. I'm going to put a point. Over to 0, up to 240, put a point. If you can find more points, then use them. Maybe there's not any more for that one. All right. Connect your points with your ruler. Try to do the best job you possibly can with graphing. Connect them very carefully. shade in relationship to that line? You shade below it, because it says less than or equal to. So you shade everything under the line. Notice I drew my line with a shape, I drew it with a solid line, not a dashed line. Now you need to do the same thing for your other line. And the other line, I think, was 2x. It was 2x. Actually, it was 2x plus y was less than or equal to, was it 320, you guys?
Yeah.
320, all right. Solve for y again. Subtract 2x. Y is less than or equal to 320 minus 2x. And I need 2 points, and I believe there are only 2 points that will fit on your grid for this one. 60. I'm sorry, what did you say? Oh, okay. I thought you were asking a question. You were not asking a question. You were talking. Okay. 120 and 80. Does that work?
Yeah. 60 and 200.
All right. So, whoops. So 60, and you said 200.
Yeah.
And then another one.
120.
120 and 80. So I'm gonna plot those points. 60 and 200 is way up here. And 120, 80, I go over to 120, I go up to 80. Put a point. Connect them with a solid line. Hopefully you do a better job than I just did. You have to shade underneath that line. So you're going to shade everything under it. The part that is double shaded is this part. Hopefully you are agreeing with me on this. And when you're done shading, you'll recognize that you get kind of a weird looking shape. Would you guys agree? It's kind of an awkward looking shape. I don't even know what you would call that. A quadrilateral. Has 4 sides. What I want you to do right now is circle all of the corners of your shape. Circle the corners of your shape. So this is a corner, would you agree? That's a corner. We have another corner right here. I'm going to circle it. You have another corner right here. You see what I mean by a corner there?
Yeah.
And then you have another corner up here. How many corners total? 4. 4. And what we need to do is identify what those corners are. So what is this point? What do we call this point?
0.
0, 0. Label it. 0, 0. What about this point way up here? What do we call that point?
0,
0, 240. Very nice. What about that one? Don't guess. No guessing. I want an accurate answer.
150, 0.
And I have not heard the right answer yet, so this is my point. You guys need to calculate this point accurately, and you're gonna do that by graphing both lines on your calculator and calculating a point of intersection by pressing second trace 5. So, before you even start typing in anything into your calculator, what I would like you guys to do is press window. Press window on your calculator. And you need to set up your window on your calculator to match the window here. So what are you going to type in as your x minimum? What is your smallest x value on your graph? 0. What is your x maximum? 210. Y minimum? Yeah. What'd you say? You already calculated that point? Oh, okay, good. Just hold on, okay? Your y minimum at 0. Your y maximum is up here at 280. So your window should be set right. Now type your y equals equations. Type in this 240 minus x into y1. Type in 320 minus 2x into y2. And do second trace 5, enter, 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 to calculate that point of intersection. Can I have an answer? 8160? So I look at my graph and I think, you know what, mine certainly does not look like 8160. Why is that not accurate?
Because it's you.
That's you.
Well, it's not. You're not.
It is because it's me, human error. I didn't graph it perfectly. I was drawing it freehand. Yours should be a little better, but still probably not perfect. Yeah.
I could go to,
You could what?
close, right? I was gonna say you could go to the table and check.
Yeah, you could and find out where they're equal to each other. Yep, you could do that. 80, 160, is that right?
Yeah.
Alright, we have one more corner. Don't guess. No guessing. You have to calculate accurately. 160, you think? So let me give you some clues here what you can do. This line right here, the pink line, that was y equals 320 minus 2x. This line right here was. So if I only put that in my calculator, just type this one in, 320 minus 2x. Just put that one in. Go to y2. What are you going to type into y2? Type a 0 in, yep. Type a 0 in y2. And you will get on your calculator, you won't see it, but there'll be a line right along the x-axis. And you can do a second trace 5 with that horizontal line at 0 and the pink line. And it will get you, what does it give you, Kevin? 160. Alright, so you had guessed correctly? Okay. Don't guess though, okay?
Always do the math.
I got
Whenever
Oh,
possible.
it just makes me nervous if you're guessing. I agree, it certainly looks like 160, but don't assume.
How do you know what
Because
this
when
one?
you assume, you make
Oh, so this is out here. wasn't it?
stop watching.
Alright. So we have all our points. That's tedious, kind of gets boring. List 2 feasible plans. Marcellus. need a couple. I
60
need,
and 120.
what'd you say?
60 and 120.
60 and 120 is right here. Does that fall in the green region?
Yeah.
So it's
30,
feasible.
30 and 40.
59
There's
and
60 and
119.
120, and then I need one more. Go ahead, Marcellus.
80 and 160.
80 and
160.
160. That's that point. Can we use that? Yeah. If these were dashed lines, we could not use it. But they are solid lines, so yes, we can use 80, 160. And you know what, you guys? There are so many options for those. Those are not the. Don't have to be the end all be all. All right, I need 1 point that is not feasible. A one non-feasible plan. Go ahead, Victor.
120.
120, 120. So I go over to 120. I go up to 120. I end up right here. Is that feasible? It's not in the green part. Not feasible. So I'm going to list it as not feasible.
What if one line's dashed and the other one isn't?
It can't be in the
Can't
green.
be. They both have to be solid for that to be true.
It can't be in the green.
Non-feasible cannot be in the green. Green is the feasible region.
So whatever shaded in is feasible.
Whatever is double shaded.
Okay.
Double shaded, yeah. So if I picked a point over here, it's shaded blue, but it's not shaded pink too. So that would not be feasible. It doesn't meet both of my lines, okay? All right. This, you guys, is easy, but it takes a little bit of work. You all need to be on a blank screen on your calculator. And what you need to do is calculate the profit at each one of your corners, each one of your points around the figure. So what you need to do is choose white. What I need you guys to do is take your points, 0, 0, 160, 0, 80, 160, and 0, 240, and I need you to plug them back into your profit function from the very beginning of the problem. And I need someone to read it to me. What was our profit function up at the top of your paper? What was it?
40x plus 30y.
Okay, and I'm going to say P equals, profit equals 40x plus 30y. And you need to take each one of these points and plug it back in. What's going to happen if I plug in 0, 0 into this rule? What is 40 times 0 plus 30 times 0? 0. This point right here, 0, 0, that is what I call a stupid point. It will never make you any money. Why bother checking it if you're not going to make money off of it? So I would say don't worry about checking that corner. Now what you do is check this one. Check 160, 0. So you're going to do 40 times 160 plus 30 times 0 and get me an answer. What's 40 times 160? My x value is 160. My y value is 0.
640.
So I plug in 160 and 0 into my x and y. What do you get?
640.
6,400.
I did it.
Now what I need you guys to do is check this point, 80, 160. So I'm going to do 40 times 80 plus 30 times 160 and get me an answer.
8,000.
Exactly 8,000? All right. So which one is more favorable so far?
I'm gonna go with the 8,000.
The 8,000. I have one more point to check, and that last point is 240, 0. So I do 30 times 240 plus 40 times 0. What do you get?
You did that one. No, never mind.
7,200.
Which one gets you the most money? This is the most money. The 80 and the 160 are what make you the most money. So when it asks you right down here, the very last question, blank acres of corn and blank acres of oat will maximize your profit. What are you going to write in the first blank?
80.
80. So 80 acres of corn. How many acres of oats was it? 160, and how much money did it make me?
Wait, so are you telling me this is the first time I see math to be useful in like for real?
Wait, what numbers did you plug in?
I plugged this 80 and what all the corners are what I plugged into my objective
Each
function.
number? Oh,
The X and the Y.